Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Maple School, home of the Mustangs, and we're here to Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
And in studio with us we have Anjali. And Anjali, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We are online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Anjali, where do you go to school and what grade are you in?
I go to Ronald Reagan Elementary and I'm in 6th grade.
How long have you been at Reagan?
Since 1st grade.
So you've
about
been there a
6
long
years.
time.
Yeah.
So what do you think is one thing you'll miss next year when you go to a new school?
All the teachers.
So you're gonna miss all your teachers?
Yeah.
Well, so you've had probably 7 teachers.
6.
6?
Yeah.
So guess what? Next year you're going to get 6 again, all in 1 year, right? So you know that in junior high you go to different classes and you can have a lot of instructors, right? So are you looking forward to that?
Yeah.
Perfect. That's the excellent, most perfect thing you want to say. Yes, you are looking forward to that. So what are you working on in 6th grade right now?
We're working on ratios and percentages.
And you can explain those a little bit?
Yeah.
All right. Do me a favor, head on over to the board and let Marylou know briefly what ratios and percents are and how they're alike and different.
Well, ratios are basically a comparison between different numbers. So a ratio would be, say, 2 to 3. So that would be an example of a ratio. However, a percentage is basically a ratio to 100. So a percent would be like, for example, 49%. Which is basically a ratio of 49 to 100. So whereas 2 to 3, it could be a ratio with any numbers, for a percent, the ratio has to be to 100.
Is there any other way that you can write that ratio?
Yes, you can write it as a fraction. So this could be 49 over 100, and this could be 2 over 3.
Very good. Can we do a problem with ratios?
Sure.
We're going to do plenty of problems with ratios and percents. I've got a beautiful one set up for you ladies in just a little bit. But I just wanted to get a little bit of a background right there on ratios and percents. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. We are celebrating our 20th season this year on Do the Math. It is time now for today's Math in the News. And once again, as we celebrate our 20th season, we are fortunate enough to bring back a lot of people that have been involved since the very beginning of Do the Math. In studio with us right now, we have Katie Russell, the superintendent for the Panama Buena Vista Union School District. How are you today?
I'm very well, thank you.
Thank you for coming in. Now, I know that you haven't been with the district since the beginning of the show 20 years ago, but you are the current superintendent and have been now for your second year.
Yes.
So what I, first of all, because there are some students, and I'm sure Anjali might be wondering this also, what is the role of a superintendent?
Yes, many people look at the role and say it's big, but I go right to my main job as a superintendent is to make sure students like Anjali have a safe learning environment. It all comes down to there, and I loved hearing her say she really likes her teachers, and it's so important to get quality teachers in front of our students so that they can learn every day. And so I also think one of my jobs is making sure that we hire the best teachers to service our students to make sure they're successful.
Well, I will let you, I am one of your
Yes,
teachers at
you
the
are.
Panama School District. And how have you seen the district and school in general evolve from last year, your first year, a pretty big and hectic year,
Right.
to this year?
Yeah, you know, as many people watching know, a lot of our students were online most of the year, and even when they came back, they were in small groups.
Right.
And so the biggest difference really is the learning environment that we've been able to bring our students back fully 100%. And when you think about all the work and the problem solving, and you even think of math and what needs to happen, it's so nice to have our kids back where they have the opportunity to engage with their peers, because that's a big part of their learning too, is that engagement.
Right, because I know when students come in and they're on the program and we ask, how's it going? And one of the common answers is, I like being back at school because I can see my friends again.
Right.
And
right.
I think that mental part is a big benefit for the students and how they go on learning for the rest of the year.
That's right. And, we always talk about two halves. A whole education is academic and social emotional learning. And being in class, the ability to be close with your teachers, learn in person is critical to the social emotional learning as well as the academic piece.
Right, and just being able to problem solve
Correct.
with each other, having somebody to bounce ideas off of and things like that. Like we say, when we're in here doing math problems, a student may do it one way, and then a tutor might be able to show them another way,
Yep.
and then we can also show them another way. So there are a lot of different ways, but students wouldn't be able to get that necessarily unless they were able to work directly with other students and their peers in problem solving, things like that.
Right.
So I know that Panama was the first school district to come on board with Do the Math 20 years ago when this whole thing started. So the county office reached out to different school districts, and Panama was the first one to say, yes, we will do this. And if I'm not mistaken, Doug Miller at the time was the superintendent. I don't know if you guys have had an opportunity to meet.
Yes, he actually lives down the street from me.
Oh,
so.
good. Well, I see Doug occasionally at the store,
Yes.
and I always thank him because he was the one that brought me into the district. But how do you see Do the Math as a superintendent of a pretty large school district? I mean, you are probably one of the largest in all of Kern County. How do you see Do the Math benefiting students, and how do you see them using it possibly in the district?
Yeah, so first of all, I'm so proud that our district chose to do that, because when I started to learn about the background and why it started and the benefits for kids, number one, kids learning from kids. When you have a student up here sharing their thinking, and as you mentioned before, there's so many different ways to solve a problem. And in the 21st century, we have to create problem solvers.
That's
and
what
so
people are looking for.
Exactly, and so to have something like this and people and students able to call in that they need help, they need to see it differently, and having that access, because we can't always get all the access in that 6 hours worth of time that they're
Right.
in school. And so this show and this program allows our students more access outside of the classroom and access to adults and other students.
Well, I'm glad you brought that up, because many moons ago, 20 years ago when we first started this, I'd be up here doing problems and the other tutors, and the show has evolved over the years, and there have been a lot of new components every year. But one of the most successful things that we've done is to bring students on. Because after a while, it's like, hey, listen, old man, I like the way you're doing the math problem, but I don't want to see you keep on doing it like that. I watch old people do it all day long.
That's right.
So I think that was a big point that you brought up, being able to see students on the program modeling for other students. And I just want personally to say thank you for continuing to support the Do the Math program, because 20 years ago when Doug, I forget, it may have been Doug or somebody else, had said, hey, we'd like you to go to the county office and check this out and be part of it. It had no idea what it was going to be exactly, and that I would be here 20 years later still doing it. So I just want to say thank you for the district to continue to support the program, because I get a kick out of doing it. So.
Yeah, absolutely, and we want to thank you, because everything that you're doing is supporting our students like Anjali. So
All right.
we're
Well,
very
you know
happy
what?
to
We
support.
appreciate your time coming in. I know that as a superintendent, you must be very busy. But that is today's Math in the News. Katie Russell, the superintendent from PBVUSD, as we celebrate our 20th season on Do the Math. In studio, we do have Anjali, a 6th grade student from Reagan Elementary School, and we have one of her math homework problems we're going to take a look at right now. So let's put it up on the board. And Anjali, we'll take a look at this. And it says, in order to get credit, show all of your work. And you underlined that. So that's good. So the skull, so I want you to write down anything that you think will be important. The skull accounts for 15% of the weight of a beast's bones. All right, a beast's bones account for 21% of its total weight. All right, so what is the total weight when the skull weighs 570 pounds? So you and Marylou will work on this, and you kind of direct Marylou how you want to go about this, and she's right there to help you out.
First, I want to see how much the beast bones in total are.
Okay.
And then, so we have to use the amount that the skull is 570 pounds.
So do we know, okay, keep going.
And then we can reduce this to make it easier to 3/20.
So when you say that, I know exactly what you're doing, and Marylou, I don't know if you're going to catch that, but say it again, Anjali.
Yeah, I was going to ask her, what are we solving first? Are we going to find the total weight first, or are we finding the skull, the 15% of the beast, which is the skull is the 15% of the beast bones?
Well, we already know the skull, so we're trying to find a total amount. We're trying to find the beast bones.
Okay, but is the skull part of the beast bones?
Yes.
It is part of the beast bones. So it is included in that 21%, because the 21% is the total of the bones. So that 15% is also included in the beast bones. So we really kind of first need to look at that skull, and we need to actually find out what the total beast bones are first, because we don't have that information. We just know it's 21%. But by using the skull, the 15% of the beast bones, then we can continue on. That's the first part that we need to find. And you do have it set up correctly, so I'm going to let you continue with that.
And the only thing I wanted to bring up is Anjali, I think, said reduce that.
Yes, she did.
So when you reduce, you're taking something away.
Yeah.
But isn't 3/20 the same as 1500ths?
Yes, it is.
So instead of taking something away and reducing it, we're just simplifying it.
Yeah.
You see the difference between the two?
Yeah.
Okay.
And again, when we're simplifying it, we're making it easier for us, right?
Yeah.
We're finding a more efficient way, because we don't want to have to multiply with the 15 and the 100, do we? We rather have it simpler to numbers.
So first, I'm gonna use cross multiplication. So 57 times 2 is 114, and then you have to add those two zeros on, and that is equivalent to 3x. And since we want to solve for x, we have to divide this by 11,400 by 3.
And I'm going to help you out with that. That will be 3,800.
And real quick, we're going to do a visual on this to kind of see what that looks like. So if we had like a tape diagram, and mine's not very good, we know that this represents the 100% of the bones, right?
Yeah.
And we know that 15% of the bones, the beast bones, is the skull, correct?
Yes.
So we know that. So therefore, we know that this is what, 570? So
Yeah.
looking at that, we do have that visualization to help us out. So what is the 100, what's the 100%? We know that the beast bones are therefore going to equal 3,800. That's really what this is saying, that the weight of the beast bones is 3,800. So taking that information, what are we going to do next with that 3,800 if we know that that is the total weight of the beast bones?
Well, we want to find the total weight of the actual animal.
Okay.
So we have,
And you can move the screen up if you want to move it up on the side here. Here, I'll go ahead and do it for you real quick. Right here, we can move it up so you have more room.
so 3,800 equals over x is equivalent to 21 over 100 because it's 21%. So then you do the cross multiplication. So 21x. And then you get 38,000.
So we have 380,000.
Yeah.
And then hopefully, Mike, are you going to help us out with the division on this, or are we going to work it out?
No, I'll help you out with this because there's some rather large numbers and it's going to come out to be a big number also. So Anjali, you want to take the 380,000 and do what with it?
Divide it by 21 so we can solve for x.
Perfect. So let's put x equals, and I'll read the number off to you, 18095.2381. So now think about with all of those digits, which ones you actually need.
Well, if we're going to round to the nearest pound, then we'd only need this digit.
So rounding to the nearest pound, what is our final solution?
18,095, since the 2 rounds it down.
Okay, so again, looking at that, and because the way you had set it up, right, you set it up as your proportions. But again, for students who aren't quite understanding how to get there, we are looking at that tape diagram again, and we can do the same thing, and we actually can use estimation here. Instead of doing the cross multiply, if we know that this is 21%, right? We know the 21%, and our 21% again was 3,800. So think about that, to estimate up to get to our 100%, what could we estimate this to? How many times would you multiply that 3,800?
I would multiply it by 5 since we can change that 21, we can round it to 20% instead.
Right, and do that for me on the side up here real quick. Multiply 3,800 by 5. Oh, just click off. There you go. Your sleeve's hitting the thing, that's okay. There.
I think I skipped something there.
Well, think about this. Look at your answer.
Well,
It's about 19,000, right? Are you pretty close to what the actual
Yeah.
answer is?
yes.
And again, using that, and we rounded down. So obviously it's going to be higher. So again, we can use this as a check to check ourselves. Okay, did we get that right?
yes.
But again, you could use it, as estimation to help you get started to see where you need to go. And especially with students who aren't quite understanding how to set up those proportions, We're just kind of using that number sense to help us there.
All
There
right,
you go.
great problem, girls. Nicely done. And Anjali, I've got a question for you. When you hear the word plane, what do you think of?
I think of bland.
Okay, so that's P-L-A-I-N. Now if I tell you the other plane, P-L-A-N-E, what do you think of?
An airplane.
All right, well, let's find out a little more on today's Language of Mathematics.
Hi, I'm Cindy, and today we're going to talk about plane on the language of math. So when you think of plane, most often you probably picture something like this, some sort of airplane, and we call it a plane for short. This would be a tool that's used to plane wood to make it flat. You may think of, I don't know, a plane of existence or something like that. All right, in math, a plane is a two-dimensional surface that's flat and extends infinitely far. So you can almost picture a piece of paper that just keeps going and going and going. It has no depth, and it's just a flat surface that extends infinitely. So when you see a picture of a plane drawn in a math book, you'll often see it drawn something like this, where they use a rectangle, or in this case, a parallelogram, some sort of quadrilateral, and then they show that it extends infinitely far by using arrows. So one of the very common planes that we use in math is called the coordinate plane. When you see a coordinate plane, it helps you visualize that it extends infinitely. That's what the arrows on the edges are for. So you have your x-axis with your positives to the right. This one's only numbered to 10, but the arrow here means it continues on. You have your y-axis up here. Positives go vertically up, and then negatives go vertically down. Your x-axis has the negatives on the left. There's arrows on each end to show that it extends infinitely in all directions. So even though you might have a piece of paper with a coordinate plane on there, there may be points that you can't fit on your piece of paper because the way yours is numbered, they would end up off somewhere off of your paper. Okay, the thing about a plane to keep in mind is it doesn't have any depth. It's a flat surface. So one way to think of that is you have these points that are plotted on this coordinate graph. And if I were to plot this point, it's no more deep than plotting this point. You don't push into the paper further to plot A compared to B. Okay, so when you plot the points, they're all the same depth. So just picture it with the arrows on each edge. It continues on infinitely, and that will help you understand what a plane is in math. This is the language of math, and this is what a plane is.
All right, there we go. So something different with plane, huh?
Yeah.
All right. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We are celebrating our 20th season on Do the Math this year, and we have a lot of great guests coming in throughout the year. In studio with us right now is Anjali, a 6th grade student from Reagan Elementary. And Marylou, you have done the 4 fours before, haven't you?
Yes, I have.
Yes, you have. So we're going to have a nice little treat for Anjali. Marylou, do me a favor and put up 4 fours on the board,
Okay.
because you know how I'm going to need them spaced apart.
Oh, yes.
Anjali, I would like you to think of a number between 0 and 10. And you can go ahead and say it out loud.
8.
8. So put equals 8 at the very end of that. After the last 4, put equals 8. Now, you're familiar with the order of operations?
Yes.
Okay, so you can add, subtract, multiply, divide. You may group numbers. You may use any mathematical symbols you like. But you must use 4 fours in order to get 8. So, go to it. I will give you, let's say, 4 minutes. All right, go.
So tell me your
Oh,
thinking.
she's right on it.
Okay,
You're right.
tell me your thinking. What is your thinking?
I
Wow.
was thinking of multiplying, because if you have 4 fours, 4 times 4 equals 16.
Okay.
But then you would need to get rid of 8. So I decided to just multiply these together, then group these together and subtract it out.
Okay, show me. So we have 4 times 4 is?
16
Okay.
minus 8, which equals 8.
That was way too fast.
There you go.
That was
Nicely
awesome.
done. So what I want you to do is erase the 16 minus 8 equals 8. You just use the eraser, turn it backwards and circle it.
Yep, and then go all the way around and touch on the screen. There you go.
Okay, so leave that one up there. What I want you to do is I want you to find a different way to get 8.
So what's a different way, other than what you just did? Show us another strategy. And remember, you can use fractions if you need to.
So how would I make the fractions? Could I use just divided by any number?
No.
Or do I have to use these numbers?
You have to use all the 4s, but then you have to use 4 4s.
So if you put 4
So if you do 4 over 4, that would be 2 4s.
But that would be the same thing as going 4 divided by 4.
Exactly.
So leave the one you've got up there. Just underneath it, write 4 4s again. And come up with another way to get 8. Yeah, you've got it. I see what you're doing.
Okay, walk me through it.
So 4 divided by 4 equals 1. And then we go to the brackets, which we multiply by 4, which we then get 4. Then we add the 4 to get 8.
Oh,
Nicely done.
nicely
So
done.
what I'd like you to do is above the original 4 4s, put 4 more 4s. Because we've got so many different ways to do this.
Yes, we do.
Okay? And here's your challenge now. You can only add and subtract. No multiplying or dividing in this one.
So only adding and subtracting. Okay.
So if you add 4 plus 4, we don't really need this because of order of operations goes left to right. But 4 plus 4 plus 4 equals 12 minus the 4 equals 8.
Nicely done.
Very nicely done.
All right? So you've done those quickly. And I like how sharp you are on
Yes.
that. You must have a very good instructor somewhere. And you're a very sharp student also, I can tell you that. So right now, because you have done some great work, we're going to award you with a meal courtesy of our friends at the Broken Yule Cafe. So congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30, and we did have an opportunity to go visit our friends at Maple School. Once again, we're at Maple School. We've got some young ladies in 6th and 7th grade, home of the Mustangs. How many of you have been here for a long time? Have any of you been at a Mustang for a long time? How long have you been a Mustang?
Since I was in TK.
Since TK. Whoa, that's about as early as you can get, right? Okay. So, ready for the next math activity. So, the green cards all have single numbers on them between 0 and 9. The pink ones have higher numbers on them, okay? So, what we're going to do is we're going to flip over 5 numbers, green, okay? So what I'd like you to do is flip over 2 of those, and I want your side to flip over 3. Okay, so we can write them down. So this would be a 6, and that's a 9. So we have a 6, a 9, and then a 5, and a 7, and another 7. So those are the 5 numbers we're going to work with. Okay? So we can use these numbers in any way we want. We can combine them, okay? We can do anything we want with them. But we need to make them equal to 58. All right? So go. Let's start thinking about it, all right? We want to do something where we can get these numbers equal to 58, if at all possible. Add, subtract, multiply, divide, square root, parentheses, anything at all, okay? So let's see, we know 6 times 9 is 54, so we could do 6 times 9 is 54 plus 5 is 59. And we need to get to 58. So I think I've got us off on a pretty good start here. If we go 6 times 9 is 54. Plus 5, this all makes 59. Now I need to use 2 sevens and subtract 1. So how can I get 1 by using 2 sevens?
Subtract, oh no, that would equal 0.
If I have 2 sevens, how can I make them do something to them so I get 1? Well, think about it. You divide, you subtract,
Oh,
right?
divide.
Oh,
Divide.
right. So you subtracted first, right? I gave you 0. If I divide 7 by 7, what do I get? 1. So I know this is going to equal 1 if I divide both of these. Now, how should I write this? Because you've heard of order of operations before, right? So we know we want to go 6 times 9 plus 5, and then we want to take away 1, which is taking away 7 divided by 7, right? So I've got it written like that, but now I need to make sure that I can write it correctly with order of operations. So see if you can work on that. We know it's 6 times 9 plus 5 minus 7 divided by 7. But think about, where do any parentheses need to go? Because we want to group things together, because we want to make sure the 7 divided by 7 is grouped together so that that makes 1. Yeah, I think you were looking pretty good there. Yeah, you're fine. Yeah, you can use more than one set of parentheses because you do want that together, right? So just think about what you're going to put in between those 2 sets of parentheses. Okay, so let's take a look. What was your name again?
Callie.
Callie. So explain to me what you've got here.
I did 9 plus 6 plus 5 in parentheses.
And what will that equal?
That would equal 59.
And is it 9 plus 6? I think you said 9 plus 6, but we want 9.
Minus 6. No.
We want a big number.
Oh, times.
There you go. That's okay. So think about what she's saying, all right? So 9 times 6 is 54, plus 5 is 59. Does that make sense to everybody? Mm-hmm. Okay.
And then I did 7 divided by 7 in parentheses.
Good. And 7 divided by 7 is 1.
1. And then I would subtract those from each other.
There you go. So 59 minus 1 would make 58. Does that make sense to you, girls?
Yes.
Good. So there we go. We selected 5 different numbers, and we were able to come up with the number 58. So it's a different activity you can do, help with different concepts, all of the different operations, and work on order of operations at the same time. It's a different game every single time, isn't it? All right, there we go with the students from Maple School. Well, we had a great visit with the staff and students at Maple School, and we will see more of them throughout this season. 636-4357 is the phone number. In studio with us, we have Anjali, a 6th grade student from Reagan Elementary, ready to work on another problem. So this one's going to be a little different than what you've been working on. All right, so head on over to the board, and you can write down any information that you think you'll need. Tom went to a store and spent 1/3 of his money. He then went to another store where he spent 1/3 of what remained. He then had $12 left. We need to know what the amount of money was that he began with. So
where do you think you want to start?
First, I want to find out how much he had after he spent that 1/3 of the original.
Okay.
So to find that, I have to find the total of the remaining money. So he spent 1/3 of his money originally, and he spent 1/3 of that money. So 12 equals 2/3 of that remaining money. So I can find out what the actual, what x is. So 3 times 12, that's 36, which equals 2x. Then I divide both by 2, get 18 equals x.
So is 18 is your total amount?
No,
of-
it's the remaining money.
Okay, so it's the 1/3.
Yeah.
Okay,
So 18 equals 1/3 of m. So then we do the same, 2/3 of m. So 3 times 18, that's 54, equals 2m. You divide both by 2, and we get 27 equals m.
there you go. So he had a total of,
$27 originally.
wow.
A little quicker than you thought she was going
Yes,
to get
that
through
was
with
way
one, huh?
quicker.
So do you have another way
I-
that you would like to go over that with her?
Yeah,
So other students might see, all right, I see what you did. So Anjali, what we're going to do is we're just going to go back to that screen.
yeah, so go back.
I can
Let's
do
see.
that quickly for you here. Let's do this, and
There we
maybe
go.
on the side, we'll put up the other way.
Okay, so we're looking at this as a whole, right?
Yes.
So we have our whole. We know that out of this, they spent 1/3 of the money, right?
Yes.
So we have 1/3 of the money left. And from that, I'm going to break this down to 1/3. So we know that they spent 1/3 of it, which giving them $12 left, correct?
Yes.
So if this is all $12, then therefore this must be $6. So if we know this is 6, then this is 6. If this is 6, then we know the whole part is
18.
Now we're looking at it. The 18 is out of the whole, right? The 18, as you said, is the 2/3 of the money. So if we break it down, we have 9. So we have 9, we have 18, because each of these is 1/3. And we know that they had spent 1/3 of the money, which was the 18, giving us $27. So again, looking at it that way and working backwards that way.
Good.
So again, we have our equations and then we have our visuals.
But I was going to say, there's always more than one way to solve a problem, and you just illustrated that beautifully. All right, you know what? I have some other great problems for you, but we'll do it right after this.
This week, Lab TV travels to an Air Force research lab in Dayton, Ohio, where engineers are powering some cool devices by perching them on power lines.
What we do is we harvest the energy directly from the power lines, so these systems can operate 24/7, 365 days a year. You don't have to replace batteries, nothing. You just install them, you walk away.
These engineers have figured out a way to harness electricity from power lines without going into the wires. But when they started this project, they had a lot of questions.
One of the questions we needed to answer was, could we put cameras and radio transmitters and receiver on a power line and have them work without having the power line causing interference? And what we found out was, yes, we could. So once we determined that we could put things on a power line and they could work, the next step was now we needed to be able to actually harvest power from the power line and power the electronics.
The type of power in power lines is called AC, or alternating current electricity. Batteries use DC, or direct current electricity. Those electrons only flow in one direction. With alternating current electricity, the direction of the current reverses, or alternates, 60 times a second. So the charge at the ends of the wires alternates between negative and positive. That creates a magnetic field around the wires, which is the key to power harvesting.
These systems will get their power based on inductive coupling. When current flows through power lines, current emits a magnetic field. This magnetic field is existing in all the power lines all over the world. What we can do is we can take advantage of that and come up with a circuit that surrounds the power line and actually captures that magnetic energy. By capturing the magnetic energy, we can turn it back into electricity and use that to power a variety of circuits and electronics.
That process, called electromagnetic induction, also powers generators, motors, and even electric toothbrushes. Here, a silicon steel split core wraps around the power line and concentrates the magnetic fields. And then a coil of wire wrapped around it generates electric current. So the AC electricity flowing through a wire can generate electricity in another circuit without actually touching it.
This first guy was running off a battery. The next guy was actually powered off of the power line using our power harvesting techniques.
And these devices, perched on power lines, would be pretty hard to spot.
They're installed off the ground, they're 50 feet up, so they're kind of hard to see. If you're driving down a road, they almost look like a part of the power line.
Now that they can harness the electricity, they're developing small helicopters that will lift the sensor devices onto the power lines.
In this particular configuration, it takes all 8 props to lift a 10-pound payload, which is with the weight of this particular sensor. So as the sensor technology gets better and these become smaller, this aircraft can also become smaller.
And eventually we are going to have a rotary version of these sensors that will fly up 1,000 feet, for example, take a couple of snapshots and then fly back down.
Once it lands on the power line, it will transmit back the information. And using induction, it will also start charging itself.
That means we could take a system like this, put it in our power line in a remote location, and you could be sitting back in your office 2 states away or across the country, and you could have access to the imagery.
It's like when you're a kid and you're working on your bike. It's like that times 1,000. I love it. I love being an engineer. Electrical, of course.
To find out more about power harvesting and electromagnetic induction, check out labtvonline.org.
Boy, it is just endless. Science, technology, engineering, and math, and all of the different things you can get into, especially if you are young right now and trying to think about, ooh, what I want to do when I get a little bit older. You know what? You're here, Anjali. Have you given any thought as to what you might like to do when you get a little bit older?
I'm not completely sure. Maybe something regarding biology?
Okay. So have you done something in the past that has kind of sparked this a little bit, or you just want to learn more about it?
I want to learn more about biology.
All right. Well, you know what? When you get into junior high, you'll be learning a lot more about biology. You ready for another problem?
Yes.
You ready for a puzzle?
Yeah.
All right, good. So here are some different cards, okay? So what I'd like you to do is you can kind of sort those out. Let's go through them one at a time so that the students at home can see the cards as well, all right? So maybe we'll just do one. So go ahead, read the card, and then maybe move it to the side, and we'll go on to the other cards.
There is a red block directly below a yellow block. There is a green block on the bottom level.
It's okay. So there's one set of clues we have, all right? So let's get rid of that, move it off to the side, and we'll go to the next one.
A blue block shares a face with a yellow block. There is a red block on the bottom level.
Sounds kind of confusing so far, doesn't it?
Yeah.
All right, let's move it off and get another one.
A blue block touches red and green blocks only along edges. There are 3 blocks on the bottom level.
Okay, so far we've seen, you know, like a face and an edge. So quickly, before we keep going, here are the blocks you're going to be using. Can you explain to me what a face is and what an edge is and where they might be?
Well, a face is this part, and an edge is this corner piece, kind of like a vertice.
Okay, so would an edge just be the corner, or would it be the
well,
whole?
it'd be this whole side.
There you go, all right. So let's go on to the next clue.
A yellow block touches an orange block only along an edge.
It's a good thing we know what an edge is now, right?
There is a red block directly on top of a yellow block. The highest block is on the 3rd level.
Oh, so there are going to be a couple of levels to this thing now. All right, let's keep going.
There are 6 blocks in all. An orange block shares a face with a green block and 2 others.
Okay, well, Those are all your clues. You think you have an idea right now how to put them together?
Yes.
After going through it one time, you think you put this whole thing together?
Well, not the whole thing, but as I look again at it.
Good. All right. So here are your blocks. Go ahead and do whatever you need to. And as you're doing it, explain to us what clue you're looking at and how you're putting this together.
Well, first I want to see which ones are on different levels before I actually start building it. So I know that there are 3 blocks on the bottom level. And here there's the red block, a green block. There's a red block on the bottom level for sure, a green block, and that's all I know for now.
Okay.
For the next level, well, for the 3rd level is the highest level on one of the clues. So, and then there are 3 blocks, so. There's a red block directly below a yellow block, so that makes me think, well, there's another red block, but that makes me think that there might be a yellow block on the 2nd level. I don't know this for sure, but it gives me a hint. There is a red block directly on top of a yellow block, which makes me certain that the yellow block is on the certain level, and a red block is on the 3rd or highest level. Then I have to sort out these 2. An orange block shares a face with the green block and 2 others. Well, if these are like this, then I'd want another face. So it can't be right here, because then it'd only be shared with 1 or 2, but not 3. So I'd have to have it here, where it shares with 2 blocks. And a blue block touches red and green blocks only along edges. So, touches red and green blocks only along edges.
Now remember, if you need some assistance, Marylou is right there for you. You can ask her some questions or see if she has some input on this.
Can I
So
have some input?
think about the edge again. Where's the edge at?
Well, an edge is right here, so
Okay.
it barely touches it. So if it was right here, then it'd only touch it right here.
So,
But it also has to touch a red block.
okay, does it say though that it touches on the same edge? Or
No.
could it touch on 2 separate edges?
Could touch on 2 separate edges.
Now remember,
But
you
it
had
says-
something
yeah.
about a highest level.
Yeah.
So everything's not going to be at the same level
level.
here. You're going to have to build up somewhere along the line here.
So it's coming up. It's not flat. We're not talking about 3 flat layers. We're talking about building up. So we're going to have to be stacking. Are we going to be stacking these then?
We're going to put them on top of each other.
Yes. So we're going to be stacking.
So let's go to the ones about the orange blocks again. So a yellow block, well, touches an orange block only along an edge. So we know this has to touch a yellow block, but only along an edge. And then I think this might be our thing, but we have to check. So it shares a face with the green block and 2 others. Well, this doesn't share with the green block, so we know it can't be true. So there are 3 blocks on the bottom level. So say we were to rearrange this, then let's go back to the blue block. So it shares a face with the yellow block.
And when you think that there's one on top of another one, show me a blue on top of a red. Okay, all right, that's why I wanted to make sure. I just wanted to make sure that
Yeah.
you weren't thinking that this is a yellow on top of a red this way.
No.
Okay,
Shares a face with a yellow block. There's a red block directly below a yellow block. There's a green block on the bottom level. That's nice. There is a red block directly on top of a yellow block, yes. The highest block is on the 3rd level. A blue block shares a face with a yellow block. There is a red block on the bottom level. A blue block touches red and green blocks only along edges. Yes, well, not here. So say we were to rearrange it.
So let's see, what does that look like stacked? I really appreciate how you laid it out, but let's stack those because you talked about stacking them. So what does it look like stacked? So now let's go through the cards one more time.
There are 6 blocks in all. An orange block shares a face with a green block and 2 others. Shares it with a red and a blue.
Okay,
so
hold on. The orange block shares a face with the green and 2 others?
yeah.
Okay.
Oh, now I see my mistake.
Okay.
So this has to be in an area where it shares it with 3 others. So it has to be touching the other ones. So if it was in the middle, then it had to have one on this side.
Well, let's go back to the stacking, okay? You stack that back where you had it with the blue and the orange. And let's think about, will it go in order from large to small, or can we move that green somewhere else?
Well, we can move that green somewhere else. We can just rearrange the shape of them as long as they're touching the right ones.
Okay, but do they have to go vertical or horizontal the way you have it?
They can go horizontal
I mean,
too.
you have them horizontal, meaning the way you have it laid out, but does it have to go in that order?
No.
Can we move the green, because what is the clue for the green again? Oh, there you go. Let's read the clue for the green again.
There is a green block on the bottom level.
Okay. It's on the bottom.
We know that. And then
Then look for blue and orange
Yes.
also.
What does the blue and orange say?
well, a blue block shares a face with a yellow block.
Is the blue sharing the face with the
Nope.
yellow? Okay.
And then for the orange block, an orange block shares a face with a green block and 2 others.
So if we have it like that, we have it, the orange, is it sharing with a red?
Yes.
It's sharing with the green.
Yes. But
Would you say the top where the blue is are those sharing faces
yes, one
as
face,
well?
Yeah.
Okay. Continue on.
A yellow block touches an orange block only along an edge. It's that edge right there.
Okay.
A blue block shares a face with a yellow block. True.
Okay.
And there's a red block on the bottom level. There is a red block directly below a yellow block. There is a green block on the bottom level. A blue block touches red and green blocks only along edges.
And is that happening?
Yes, because
Okay.
it's that edge and that edge. And there are 3 blocks on the bottom level. And the last one, there is a red block directly on top of a yellow block. The highest block is on the 3rd level.
And there you go. Have we gotten all the cards?
Yes.
That is correct right there. Nicely done. What do you think of that one? Pretty good problem?
Yes, it definitely made me think a little more.
There you go. Well, that's exactly what we wanted you to do. We wanted you to stretch that brain a little bit.
And the one thing, everybody wants to line them up from
Right.
largest to smallest, but that's not necessarily the order sometimes.
It can be in any,
Exactly.
Do you think you can do a math problem in 4 minutes?
maybe.
I know you can,
I-
probably. Head to the board, young lady.
I give her 1.
Have you done percent of increase yet in class?
I don't think so
Oh,
yet.
you will be, so here we go, all right? So Mary Lou's gonna help you out.
'Kay.
All right, so the original price, okay, we're gonna start off at $110. 110. And the new price is $135. So Mary Lou is gonna help you figure out and come up with the
Percent of change.
right, how do you do that? Okay, so Mary Lou's gonna have to first guide you through the formula, and then you girls can go do
Well,
it.
first off, what are you thinking?
First off, I want to see what percent of 135 is 110.
Okay, well, the first thing we need to do is this, actually, is just to find the difference of the numbers. That's it. So what's the difference of the numbers?
25, and then
Okay.
we can find out what percent of 25 is of 110.
Yes, absolutely.
So 25 over 110 is equivalent to x over 100. So then we can simplify this actually and divide it by 5. So 5 over, that's 22. And then x over 100. If we cross multiply, that would be 500 is equivalent to 22x. Then we divide.
So remember, we're dealing with money?
Yeah, so we go to the hundredth.
Right.
And then do we need the 1,000 to round it up, or?
Yes, we do.
So then we have the 22.72 because of the 44. $16, bring another 0 down. So that's 160, which we already did here. Goes in
Okay.
7 times, and that's all we need.
Okay.
So we can change it to 22.73, so percent increase.
So we have a 22.73 increase. There you go.
Nicely done. So Anjali, when you were working that out, and you've done it beautifully, when you brought down one of the zeros, you went 22 by 7, because you had to get close to 160. What was going through your head that you knew that 7 would be the best possible way to start?
Well, I know it's more than 5 for sure, because 22 times 10 divided by 2, so 200, it's 110 if you work it out mentally. So then I know it has to be more than that. I know 110 plus 22 wouldn't be enough.
Okay.
So I decided to go around with 7 and see if that would work. And if that didn't work, then I'd know if I'd have to put it down or make it higher. And then when I found out it was 154, I knew to go into 160 fine without me having to change the number at all.
Right. So perfect using the mental math right there.
Yeah.
Yep.
Estimating, like you and Marylou were before, you know 22 is about 20, so 5 is going to be about 110. You can do that mentally. And then from there, you estimated and got the perfect answer. So nicely done. Anjali, I've got 2 questions for you. Did you learn a little something today?
Yes, I did.
Oh, good. I'm glad you did. You exercised your brain quite a bit today, right?
Especially with that problem.
Oh, good. I'm glad. That's exactly what we wanted you to do. And more importantly, did you have some fun today?
Yes, I did.
Well, good. I'm glad you had some opportunity to come down and visit us today. We celebrate our 20th season all year long. We do have phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.